Jupiter's Great Red Spot rotates counterclockwise, with a period of about 4.5 Earth days or 11 Jovian days as of 2008. Measuring 16,350 kilometers or 10,160 miles in width as of April 3, 2017, the Great Red Spot is 1.3 times the diameter of Earth. The cloud tops of this storm are about 8 kilometers or 5 miles above the surrounding cloud tops. The storm has continued to exist for centuries because there is no planetary surface, only a mantle of hydrogen to provide friction. Circulating gas eddies persist for a very long time in the atmosphere because there is nothing to oppose their angular momentum. Infrared data has long indicated that the Great Red Spot is colder, and thus higher in altitude, than most of the other clouds on the planet. The upper atmosphere above the storm, however, has substantially higher temperatures than the rest of the planet. Acoustic or sound, waves rising from the turbulence of the storm below have been proposed as an explanation for the heating of this region. The acoustic waves travel vertically up to a height of 800 kilometers or 500 miles above the storm, where they break in the upper atmosphere, converting wave energy into heat. This creates a region of the upper atmosphere that is 1,600 Kelvin, or 1,330 degrees Celsius, or 2,420 degrees Fahrenheit, several hundred kelvins warmer than the rest of the planet at this altitude. The effect is described as being like crashing ocean waves on a beach. Careful tracking of atmospheric features revealed the Great Red Spot's counterclockwise circulation as far back as 1966, observations dramatically confirmed by the first time-lapse movies from the Voyager flybys. The spot is confined by a modest eastward jet stream to its south and a very strong westward one to its north. Though winds around the edge of the spot peak at about 432 kilometers per hour, or 268 miles per hour, currents inside it seem stagnant, with little inflow or outflow. The rotation period of the spot has decreased with time, perhaps as a direct result of its steady reduction in size. The Great Red Spot's latitude has been stable for the duration of good observational records, typically varying by about a degree. Its longitude, however, is subject to constant variation, including a 90-day longitudinal oscillation with an amplitude of approximately 1 degree. Because Jupiter does not rotate uniformly at all latitudes, astronomers have defined 3 different systems for defining longitude. System 2 is used for latitudes of more than 10 degrees, and was originally based on the average rotational period of the Great Red Spot of 9 hours, 55 minutes, and 42 seconds. Despite this, however, the spot has lapped the planet in System 2 at least 10 times since the early 19th century. Its drift rate has changed dramatically over the years, and has been linked to the brightness of the south equatorial belt and the presence or absence of a south tropical disturbance.